Hello, algebra students. Today we're going to be talking about more multiplication properties of exponents. This is one of the more critical properties of exponents, and a lot of people confuse this with multiplying by like bases. So I'm going to address this throughout this presentation. So the first thing we have is 3 squared to the third power. What does that mean? Well, you'll notice that we have 2 powers here, and it doesn't make it much more confusing, but it is important to address. So the first thing we recognize is this third power. That means we're going to be multiplying something by itself 3 times. So what is that something? Well, we're going to multiply 3 squared 3 times. Now, underneath, I wrote these little bars here, and that's because 3 squared is implied something. That means we're multiplying 3 by itself twice for each one of these. Okay, so what happens? Well, how many 3's do we have multiplied together? 1, 2, 3, 4, 5, 6. So this became 3 to the 6th power. So this in the top also becomes 3 to the 6th power. What is the pattern? Well, let's consider it in just a second. Let's do one more just to make sure you get it. Okay, so here we have 4th power, so we know we're going to be multiplying something 4 times. Okay, what is that something we're multiplying? 2 to the 3rd. 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Now, if we wanted to, whoops, not 8th. If we wanted to, we could say 2 to the 3rd is 8 and do 8 times 8 times 8 times 8. Or we could do it the long way and say that's the same thing as 2 times 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 2. How many 2's do we have multiplied together? We have 3, 6, 9, 12. So this becomes 2 to the 12th power. So in the top, we have 2 to the 12th power. What is the pattern here? Well, a common mistake I see is people decide to do the process of adding exponents. So they put 3 to the 5th, and they say this is 2 to the 7th. This is the only time you multiply powers. A power to a power, you multiply exponents. So 2 times 3 gives me 6. 4 times 3 gives me 12. That's where that comes from. The time where you add exponents is when you have something like 3 to the 2nd times 3 to the, let's say, 3rd. That's when you multiply exponents because you have this situation. How many 3's are multiplied together? 5. 3's multiplied by itself 5 times. Okay? So don't confuse it. The only time you multiply exponents is when you have a power to a power. All other times, it's different. But the only time you multiply, power to a power. Okay? So if we have a to the m raised to the power of n, we have a to the m times n. Let's go ahead and apply that with a few examples. So here we have m to the 3rd raised to the 5th power, power to a power. We're going to multiply m to the 15th power. You can do the same thing with fractions. We have a to the 3 halves times 3. Well, we're just going to multiply here, a, and then if you need help multiplying, I always like putting it over 1, so you have top and bottom on both sides. Fractions are top times top, bottom times bottom, so you get 9 over 2. So a to the 9 over 2. You could also write it as a to the 4.5 power, but you don't see it that way often. Most of the time, you see it like that, okay? All right, so let's move on to the next one. Here we have x to the 1/2 raised to the 3/5 power. Again, you multiply the fractions, 1/2 times 3/5, bottom times bottom, top times top. We get 3 over 10, so it's equal to x to the 3 over 10 power. And then finally, we have 5 to the 1/3 times 3, or excuse me, to the 3rd power cubed. There's another way to say it. So that's the same thing as 5 to the 1/3 times 3 over 1, which is equal to 5 to the 1st power, or just 5. Okay? That was kind of a whirlwind example, but it's the same principle each time you multiply the exponents, so it's pretty easy. You can do the same thing with parentheses. So if we have parentheses here, and we're raising it to the 3rd power, what does that mean? Well, it means we're doing 3 times x, times 3 times x, times 3 times x. So now we have 3 times 3 times 3, that gives me 27, and then we have x times x times x, which is x cubed. This is the same thing as 3 to the 3rd, x to the 3rd. So anytime you have an exponent outside parentheses with multiple multiple terms being multiplied inside, like coefficients, you're going to apply this to each one of those coefficients inside, each variable, each number, whatever it is being multiplied, okay? Very important. Now we have this scenario. This is what I just demonstrated. Anytime you have a, let's use purple like we did before, ab to the n power, you're going to raise a to the n power and b to the n power, both of them. So let's go ahead and apply that. Here we have 2m to the 5th. If we wanted to, we could write it out 5 times. That's kind of a drag doing that. So I suggest taking the shortcut and saying this is the same thing as 2 to the 5th times n to the 5th. So then we get 2 to the 5th is 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32, m to the 5th. Okay, so that's that answer. Now we have to be careful with this one. Order of operations states that we need to do parentheses first, exponent second, multiplication, division last. And here we're multiplying essentially by a -1. -1 times all that. So you're going to apply the negative sign at the end. But the first thing we need to do is, because there's an exponent and multiple terms inside, we're going to multiply everything. Not multiply, we're going to raise everything inside to the 3rd power. So this is going to be equal to negative. I'm going to put parentheses just to show that we're holding that negative for last. 3 to the 3rd, x squared. And again, we're going to multiply exponent, power raised to power, multiply exponent. And then y to the 3rd, power to power, multiply exponent. So we get negative, parentheses, 27, x to the 6th, y to the 9th. And then finally, we just take away the parentheses, just make it negative 27, x to the 6th, y to the 9th. Final answer. Same thing with negative exponents. So here we have negative exponents. We're going to apply it to both. So that's equal to 3 to the -2. And then g, we're going to do power to a power, multiply, g to the -8 power. Now, if you recall, we can make these both positive. And it's not necessarily saying that here, but I'm going to go ahead and demonstrate it anyway. We can make these both positive exponents by putting them under 1. So we have 3 squared, g to the 8th. We made it positive by putting it under 1. Or 1 over 9 g to the 8th. Okay, so now we're on our last couple examples, last 2. So we have n to the 1/2 raised to the 10 power times 4mn to the -2 over 3, all raised to the 3rd power. A lot going on here, so let's take it step by step. The first thing I'm going to do is this guy. N to the 1/2 times, or to the 10th power. I say times because I know I'm going to be multiplying the exponent together. Power to a power, multiply the exponent. So we get n to the 1/2 times 10. I hope you guys recognize that that's 5. Okay, let's do this one in purple. So we have all of these raised to the 3rd power, okay, because there's multiple items inside. Going to raise them all to the 3rd power, 3 cubed times m cubed times. Now we have a power times a power again, so we're going to multiply. So we multiply -2 over 3 times 3. If you want, put it over 1. -6 over 3, -2. So this becomes n to the -2. Now we have something else. What are the like terms? Well, first let's take care of this guy. 4 cubed is 64. 4 times 4 times 4, 64. M cubed, he's going to stay by himself. M cubed. But now we have n. So the n, we essentially have n to the 5th times n to the -2. Anytime you have like bases being multiplied with exponents, you add the powers. So this is going to be equal to n cubed. So this is n cubed. And this is our final answer. Okay. If we were to rewrite this, this could be n5 over n squared. Okay. Essentially what you do is you move this to the bottom. And again, you can cancel it, get n cubed. Final example. We're going to split this one up just like we did the other one. We have power to a power. This is the one time you multiply exponents, x to the -4. And then now we have this going on where we have all of these being raised to the 4th power. So we need to raise all of them to the 4th power. So we have 3 to the 4th times x to the 4th times, power to a power, multiply y to the 20th. Okay, let's handle our coefficient first, our number. then we'll handle x, and then we'll handle y. So coefficient first, 3 times 3 times 3 is 27, times 3 is 81. Now we have x to the negative 4 times x to the positive 4. What happens there? Well, we have like bases, so we're going to add exponents because we're doing multiplying like bases with exponents. So it's x to the 0. What do you know? That's equal to 1. So we can put the 1 there, or essentially it goes away. Then we have times y to the 20th. So we're going to simplify this, 81 y to the 20th. I hope this clears this up in terms of raising powers to powers. You multiply, long story short, and I hope you enjoyed this video. I will see you next time.